Hello and welcome to another of my little videos. And in this one, we will start talking about the costs of production. Before we go into the specifics of the cost, there is one principle that needs to be remembered. It's the inverse relationship between productivity and costs. And that should be fairly straightforward. The more productive your workers are, the better it is, the lower is the additional cost of producing an additional unit. So, on the very fundamental level, we start with what we call the production function. On the x-axis, on the horizontal axis, we have input. Input, simply number of workers. We assume that in the short term, your fixed assets cannot be changed, so your buildings, your machinery, your equipment, that stays fixed. However, your labor, number of workers, can be changed in the short term. And on the y-axis, you have the output. Number of, I don't know, t-shirts or tables or whatever it is that your company is producing. So, how will this relationship look like? Well, first of all, it's pretty straightforward that it will be upward sloping. But it will not be a straight line. The relationship, let me use a different color here. The relationship will look like this. It will be convex at first. We have a smiley face here up to this point, and then it turns into a sad face, turns concave. So, what does this mean? Why does it look like this? Imagine for a second that I have 20 workstations, 20 computers, 20, I don't know, sewing machines, whatever. What happens when I go from 0 labor to 1? I hire 1 worker to service 20 workstations. That worker will not be terribly productive. And the reason is obvious. He or she will end up running around trying to service all the 20 workstations. So the extra output that I achieve by hiring this extra worker will actually be quite small. So you see the line is upward sloping, but this product, this extra product this worker produces will be low. All right, so I now hire worker number 2. That will increase my worker number 1's productivity. And the reason is simple. Now, instead of servicing 20 workstations, each of the workers will simply divide them in half and will service 10 workstations each. So you see, the slope is beginning to increase. Productivity begins to grow. I hire a 3rd worker, worker number 4, number 5, and so on and so forth. You get the picture. Hiring each additional worker will increase the existing worker's productivity up until point A. Point A here. Right? At point A, I have 20 workers working 20 workstations. What happens as I hire worker number 21? My output will still go up because that worker will fill in for someone who has a smoking break or whatever, who has goes out for lunch or gets sick or something. But you can see that as I keep adding my workers, productivity begins to level off and eventually will drop. The line is still upward sloping, but you can see that the product, that the extra product, that extra number of tables or t-shirts or whatever your company is producing begins to level off. This is called diminishing marginal productivity. In plain English, meaning that as long as you have a fixed number of workstations, eventually adding more and more workers simply doesn't work anymore. Right? Simply, you are constrained by the fixed number of workstations. Diminishing marginal product. So, on the graph, it looks like this. So again, I have my input, number of workers on my x-axis, and I have MP, doesn't stand for member of parliament, stands for marginal product. So what does that mean? Marginal in economics means additional. It's the additional number of t-shirts that one additional worker will produce. So marginal product is increasing. The number of t-shirts that each extra worker is producing goes up. Again, use a different color here. Well, not the prettiest graph, but it tells the picture. Up until point A, productivity grows. We have a happy face here. And after point A, productivity begins to decline. Sad face. You know, sometimes in science fiction movies, you see a scenario when one corporation controls the whole world. From economics point of view, it just doesn't make sense. No matter how large your corporation is, think Amazon, think Google, think, I don't know, Boeing. At some point, diminishing marginal productivity will kick in. All right, we will pause for a second as I need to clean my board up, and we will start talking about the costs. Since productivity is important and interesting, but at the end of the day, it's not the productivity that's driving your decisions. These are the costs, which of course are directly related to our productivity. Welcome back. My board is now clean, so we can get a couple more graphs here. All right. We have discussed the relationship between the input and output. Input, again, being number of workers. That's the easiest concept to think of. Output, again, number of t-shirts. The more important relationship that we need to consider is the relationship between the output and costs. So cost is measured in dollars, output in number of t-shirts. Now, if my output is 0, will my cost be 0? The answer is obviously no. My cost will not be 0 because I have fixed costs. And I suppose the elephant in the room that we need to address are the current lockdowns that we are experiencing, and businesses, even though a lot of them have an output of 0, cannot actually reduce their cost to 0. So we start right here. FC does not stand for football club, stands for fixed cost. And of course, the more we produce, the higher the costs are going to be. So it will be an upward sloping relationship. But again, it will not be a straight line. And the reason for that, we have discussed a little bit earlier in this video. And the reason is productivity is changing. Remember, I start at a very low productivity point. And as I keep adding workers, productivity goes up. What happens after some point, as my capacity gets to the limit, productivity will then drop. Well, it's not terribly hard to figure out the relationship between output and cost then. TC here stands for total cost. And this is my point A. It's not meant to be exactly horizontal. I mean, the line is still going up. Productivity goes up. Costs begin to grow at a slower and slower rate. At point A, my workers are the most productive. After this point, my costs will begin to increase at a higher and higher rate. So, I have output, and here on this axis I have MC. Does not stand for master of ceremonies, stands for marginal cost. additional cost of producing each additional unit. So the relationship is fairly obvious. Marginal costs decline and then grow. If you rewind this video, unfortunately, I have erased my previous graphs. I have no option of going back. But if you rewind this video a little bit, you see this as a mirror image, 180-degree mirror image of the marginal product graph. Productivity up, costs down. Productivity down, costs up. As simple as that. I need to pause the video again, as I need to have a third set of graphs to complete this picture. So I will see you very shortly. Welcome back. My board is clean again. So in the third segment of this video, we will start talking about average costs. Because what is important really in a production decision is to compare the price at which you sell your product to, well, how much did it cost me on average to produce it, rather than total numbers, which may be quite difficult to estimate. So we have average fixed cost, which is simply fixed cost divided by output. We have average variable cost, AVC, which of course has a very similar definition. And then average total cost, which is, well, the summation of the two. All right, so we'll start with the easiest one, average fixed cost. Fixed cost, by definition, is fixed. It doesn't change. As the output goes up, average fixed cost goes down. So the graph will look really, really simple. So we have output, cost, here we go. Downward sloping line. Think of a company like BP or Royal Dutch Shell or Texaco, some large oil producing company. Think of oil production process. Before the first barrel is pumped out of the ground, you need to explore, you need to drill, you need to build pipelines, you need to build terminals for your tankers, you need to build refineries. You basically spend tens of millions, if not hundreds of millions of dollars before the first barrel of oil is ever pumped out of the ground. And that's the reason why these companies are so huge. It makes absolutely no sense for them to be here. It makes sense for them to be here. You no doubt have heard the term natural monopoly. And people think that they're called natural monopolies because they deal with natural resources, which is partially true. But the main reason, it's simply natural for these firms to be very large. Again, think Massey University. In my budget, I am an associate head of school, so I manage at least part of the school's budget. 92% of my costs are fixed. 92%, only 8% of my costs are actually variable cost, and vary with some variables that didn't come out right. Therefore, in order for us to survive, in order for us to be viable, we have to have large output. We have to have a lot of students. Students go away, we end up at this point where our average fixed costs are astronomical. So yeah, if your fixed costs dominate your cost structure, makes sense for you to be as large as you possibly can. Now, average variable cost, that is a little bit tricky. Because if you look at this formula, we have variable cost in the numerator, which increases, and we have output in the denominator, which also increases. So the relationship, the graph for the average variable cost will be a little bit more challenging. So again, cost output. Well, as you can see by the shapes of my lines, artistic ability isn't my main talent, so I hope to compensate with a little bit of economics intuition. All right, so let's say that this graph isn't the graph between the output and the cost, but this is the graph of your grade point average in your executive MBA program. Let's say that you start off your executive MBA. What was your first class? I think it was contemporary strategy. Please do not quote me on that. I don't actually remember your schedule. You are fresh out of the gate. You're very enthusiastic. You get a very good mark on your first course. So that becomes your GPA. Then you slack off a little bit. And in your second course, you get a mark that is a bit lower. What happens to the GPA? Let me use a different color here. Your grade point average will drop with it. Next paper, next course, you score even lower. Your GPA again drops. Your fourth paper, even lower, GPA keeps dropping. At this point, your grades are low enough, your GPA is low enough that you actually start working harder again. And your mark on your course number 5 actually goes up. What happens to your GPA? It still drops. Why? Because you still have scored a mark that is lower than your GPA. Okay, that's pretty easy. And then finally, your economics class comes. You score an excellent mark, and your GPA starts increasing, and so forth. Okay, that's it. That is it. That's the intuition. The white line here, your mark on each individual course, is the marginal contribution to your GPA. This is your marginal cost. And your grade point average is the average. So the white line, the marginal cost, acts like a magnet for the pink line. As long as it's lower than the pink line, it pulls the pink line down. As it gets higher than the pink line will begin to slope up. All right, so these are all the average costs. I will again pause for just a brief moment as I need to again clean my board. And what we are going to do in the final segment of this video is we are effectively going to put them all on the same axis and finally decide what is the optimal point that minimizes our cost. Welcome back. My board is clean again. So we will now put all these graphs on the same axis. I will try to make this one a little bit larger because there will be quite a few lines that will go on it. So again, on the horizontal axis, I have output. On the vertical axis, I have costs. So my average fixed cost looks like this. I'll try to use different colors. I have a couple of choices here. My marginal cost looks like this. So that is MC. Not terribly visible on this board, so let me with a pink color. The challenges of lockdown lecturing. So this is my marginal cost. This is my average variable cost. How does it look? It looks okay. Green on green strangely looks better than blue on green. So again, the blue line pulls the green line down here and pulls it back up here. And now all I need to do is I need to create the average total cost, which is going to be the summation of the three. Oh, sorry, of the two, average variable cost and average fixed cost. So as I add it up, it will look like this. So again, it's the summation of the green line and the white line. The next question is, at which point, the graph looks a little bit messy, but I hope that each individual component here isn't terribly confusing. The most important question is, at which point do I want to produce? There are plenty of intersections, plenty of high points, low points, and so forth. And in order to answer that question, we need to figure out, well, which line do I ultimately care about? And the answer is pretty simple. What I care about is my average total cost. I care about how much money leaves my pocket. The distinction between average variable and average fixed cost at the end, it's an interesting theoretical exercise. Again, it's interesting for me to know that 92% of my costs are fixed and 8% are variable. At the end of the day, it's a curiosity, but doesn't really affect my decision making too much. What does affect my decision making is the average total cost. So once we establish that it is the pink line that is, well, the one that we want, it's pretty clear where we need to produce. What is interesting, in my opinion, is that it's actually not the same as point A from the earlier segments of this video. This is the point at which my workers have the highest productivity. The point in which I want to produce, the one that minimizes average total cost, is actually on the right-hand side. And the reason for that is the existence of fixed costs. Again, I care about minimization of the total. I do not really care about productivity per se. Thank you very much. We will be discussing this, we have been discussing this depending on the timing of this video within our day of lectures. The next video that we will talk about, in the next video, we will be talking about profit maximization decision and how we can use the cost information to achieve that. Thank you.